In solving these equations, we want to first of all isolate the absolute value expression. So we're going to do that first. We're going to do 1 minus 2x is equal to 14 minus x. So once we've done that, we now have to consider that inside being either positive or the inside being negative. So we're going to first of all establish a domain. So domain is when the boundary is going to be 0, so x is equal to 1/2. And when x is greater than or equal to 1/2, we have the positive domain. The inside is going to be positive. So then we can just say we can drop the absolute value and say that in that domain, 1 minus 2x is positive, so we keep it the same. So it's going to be equal to 14 minus x. We can find a solution to that. There's also the negative domain. So if x is less than 1/2, we're going to end up with a negative number. Sorry, that's going to be we have this backwards, don't we? X, it's minus 2x, so x is going to be less than or equal to 1/2. And then for the negative domain, x is going to be the other way around. So x is going to be greater than 1/2. So if x is greater than 1/2, we're going to end up with negative numbers inside, so we end up with that negative domain. Now in the negative domain, the inside is negative, so we need to change that inside to positive, so we can do it like this. And make that the opposite sign. That would work, or the alternative, we could look at it from a slightly different perspective and get an equivalent algebraic solution where we just say that it equals the negative value, the negative version of 14 minus x. Okay, so I'm going to put the negative on the other side since it doesn't matter. And then I'm going to solve those two equations. So solving the positive version first, we're going to solve for x. So I'm going to add 2x to both sides, so I get positive x. I'm going to subtract 13 from both sides, so I get negative 13. So there's one solution. Okay, now we could test this to see if it works, or we could check it in the domain. The domain says x is less than 1/2, so that is in the domain, so we can think that that's a correct answer. If we want to be certain, we really should test because we might have got our domain wrong to start with. Like I did make the mistake at the beginning, so if we didn't catch that mistake, that would have looked like an extraneous solution. Solving this next one here, first going to get rid of the negative, so I'm going to end up with -1 plus 2x equals 14 minus x. I'm going to add x to both sides, so I'm going to end up with positive 3x on the left-hand side. I'm going to add 1 to both sides, so I get 15 on this side. I get x is equal to 5. Now that fits in the domain of greater than 1/2, so we can guess that that's a correct solution. However, we should really check. We really should check because it is possible to have extraneous solutions. Now, at this point, I'm fairly confident that these are not extraneous, but we really should check. So x is equal to negative 13. If I plug that in, I'm going to get the absolute value of 1 minus negative 26. So I get positive 27. Absolute value is equal to 14 minus a negative, so it's going to be plus 13. And that looks like it's going to work out. So this is a valid solution. It passes our check. We're going to check x equals 5. So we're going to end up with 1 minus 2 times 5 is 10. That's going to be equal to 14 minus 5, which is 9. We get absolute value of negative 9 equal to 9. That also works out. So that passes our check as well. Okay, so those are our solutions. Again, we visualize what this solution looks like. We end up with an absolute value graph. It's going to have a vertex at 1/2. It's going to kind of have a slope like this. And we have the linear function is going to be, starts at 14, so somewhere way up here, and has a shallower slope of 1. And so we're going to get two solutions here and here. Okay, so there's our what our graph's going to look like. It's not exactly going to be like that. In fact, I should really change that a little bit, but that gives us the idea of what the graph's going to look like. It's going to actually be more like that. And anyways, we're going to have two solutions here. This is not, the graph is not proportional, but it does indicate based on the slopes that we can get two solutions.